Hi guys, welcome to the last segment of our show. So right now, guys, we've been looking at a whole lot of things. I hope you guys have grasped everything that we've looked at. Wherever you're not understanding, just go back to the notes that you've been making, go back to your textbooks, look at all the other options that you have and try by all means to make sure that you understand this, because I promise you it is going to form the basis of you understanding your whole algebra until you finish with your mathematics career whenever you do decide to finish, right? So now we're going to look at some fractions. With the fractions, it will be adding fractions and dividing and multiplying fractions. Remember, the opposite of adding is subtracting, right? But let's look at some key words that we need to look at before doing some fractions. So firstly, we have what you call the lowest common denominator. I know you guys, you started doing this when you started, as an LCM, right? Which was lowest common multiple. Now we're going to call it the lowest common denominator, which makes it a bit easier to use in terms of fractions. Now, when adding and subtracting fractions, first you need to determine the LCD. Now, for example, if I have 1 over 4x squared and 1 over 3x squared and 1 over 2xy, you must find the LCD must be a number such that all the denominators are divisible in that without leaving a remainder. So a number that 4 and 3 and 2 can go into and not leave a remainder will then be 12, right? That we do know. Because 4 multiplied by 3 is 12, so 4 is divisible in there, 3 is divisible in there, and 2 is divisible in there. Then from there, x squared and x cubed. I know that x cubed has x squared in it and also has that x there, so it becomes x cubed, and then I also need a y because the last one has a y, right? Now, remember, when you're dealing with fractions, the goal is to always have your denominators to be the same. So you will multiply each fraction by whatever factor that will make the denominator to be the same, which is in this instance 12x cubed y. Now also, another example is I have x plus 2x squared plus 2x. Firstly, I must simplify this. It becomes still 1 over x plus 2. I'm going to leave that. But this one I must simplify to x into x plus 2, right? So you can already see that the x plus 2 is already common. So I already have x plus 2 as my lowest common denominator. And then I also need x there. So it becomes x out there. Then you will multiply each term by whatever factor that you must multiply it by in order to get that denominator that I have there. Remember, when dividing a fraction by another fraction, you always need to do what we call the tip and times, right? To simplify. Tip and times means if it's a over b divided by c over d. This is going to be the same as a over b multiplied by d over c. So what's on the right-hand side of the division sign will then be tip and times. Whatever was a numerator becomes the denominator. The denominator becomes the numerator. And then you need to factorize the numerator and factorize the denominator wherever it is necessary. Like in the previous example you saw, I had to factorize my denominator there before even simplifying this thing. Now let's look at some questions just to remember. We always need to bring this into perspective. Now we have what we call the sign change here, right? I know one person will immediately say, no, my lowest common denominator there is x minus 3 and 3 minus x. But you can change the 3 minus x to be x minus 3 by taking out a common factor of a negative, so that you then don't have a lot of lowest common denominators there or terms when it comes to the lowest common denominator. We call this the sign change rule, right? Although it's just because you're changing the sign. So that's why we're saying it's a sign change rule. Now, what this will become, it will be x over x minus 3, and then it will be negative 2 over x minus 3, right? And then immediately you know that the denominator here, my lowest common denominator here will then be x minus 3. I don't need to change anything, so it just becomes x minus 3, and this becomes x minus 2, and then that's my answer, right? You don't need to then, please, you don't cross out the x's and then do your own things after that. Please don't do that. All right, so let's look at one more example as well, and then we'll have one last one just after this. So here, remember, you need to look at whether the denominator can be factorized. If it can be, do that. If not, leave it as is. So you can already see there that 4 will never give me factors such that I get a 2 as my middle term. There is no way that will be the case. So this just becomes x plus 2 all over 4x squared minus 2x plus 1. And then the second term, you can factorize it, 8x plus 1. Then this one here will be the same as 2x plus 1 in the brackets because it's a cube, right? And this 4x squared, and then since this is a plus, it becomes a minus here, and then remember, because it's 4 there and the last one will be 1, it also becomes another 4 here, and x, and then lastly it becomes plus 1, right? And then you can take out your LCM from there, or LCD, which will be the whole thing that I have here, right? So you then can take that. So let me quickly write it for you. LCD will then be 4x squared minus 2x plus 1 into 2x plus 1 into 4x squared minus 4x plus 1. But this is one of those rare cases where the denominator cannot be factorized, right? Now, let's look at when now we are dividing. When we are dividing, what we need to do, remember I said tip and times. So this will be x into x plus 1. Already I'm factorizing. This is x squared. Then it will be multiplied by. This will be x cubed over. Here I can factorize this as well. X plus 1 into x plus 1. Then you then work it out, right? You do the cross cancellation, they normally call it that. So the squared there will go with that x there, and then this x will go into that x and leave 2 x's. The x plus 1 and the x plus 1. Lastly, my answer will be x squared over x plus 1, and that's my final answer. The beauty of mathematics. Now guys, what we've looked at so far, to simplify an algebraic expression, you need to expand, right? Whenever the terms are in what? In brackets. Also, try to collect your like terms, right? Collect your like terms and then factorize to find the simplest expression, right? And please remember the types of factorization that we spoke about: your common factor, your difference of two squares, your trinomial, and your groupie. This was our map, guys, which we looked at. We said it's algebraic expression. We expanded a monomial with a binomial, bi with a bi with a trinomial. We looked at some fractions, some factorizing, which was a common factor, difference of two squares, trinomial, and some cubes. And I hope that clarifies a lot of things that has to do with algebra. Guys, I've had so much fun with you guys. I hope you also had so much fun like I did. And after this, you are ready to take on algebra with both hands and run with it. From me to you, I shall see you next time. Remember, from the Maths Doctor, mathematics is food for the soul.